Hi there, welcome to this Elkchemist chemistry video looking at simple distillation, a separation technique. This video is going to look at the main apparatus used in distillation, along with a simple explanation of how the process works and the key steps and stages involved. First things first, I'm going to quickly talk about the key components of the apparatus diagram you can see in front of you. The red-orange arrow represents the heat from a Bunsen burner being supplied to a round-bottom flask that contains our impure mixture. The second key component is a thermometer, which is monitoring the temperature of any gases being produced by the heating of that impure mixture as they rise into this column here and then on into a side arm. The side arm leads to this glass inner tube, and around it is the third key component known as a Liebig condenser. This has cold water flowing into it and cold water flowing out at the top, and the collar itself is filled with cold water. I'll expand on the role of the Liebig condenser a little bit later in the video. Finally, there's a nozzle at the end allowing our pure distillate to drop into our collecting vessel, which is a conical flask, where the pure distillate is being collected. Now I'll talk about when it's most appropriate to use simple distillation as the most effective separating technique available to you. Simple distillation works really well if you're trying to separate a solvent, i.e. the liquid which dissolves a solid, from the solute, the solid which is dissolved into the solvent when it's in a solution. If you heat the solution within the distillation apparatus, the solvent should be the substance which will evaporate and move through the distillation equipment and apparatus, whilst the solute will be left behind in the round bottom flask and separated. So the technique works based upon separating two substances that have significantly different boiling points from each other, i.e. one substance will boil at a much lower temperature first in this process, leaving the other behind. I'll expand upon that point in a second. Let's go through a simple example of a distillation experiment in a step-by-step manner. Imagine I wanted to separate water from salt water and collect that water as a pure substance. What I need to do is I would place my saltwater solution into a round bottom flask and connect it on to the distillation apparatus. I would then heat that impure mixture of salt water using a blue Bunsen flame below the round bottom flask. The water, which in this case is the solvent, has a much lower boiling point than the salt solute dissolved into the water. Therefore, the water will boil whilst the salt will not, and is left behind in the round bottom flask, whilst the water vapour or steam will rise up the column and through the distillation apparatus to the next step. The water vapour or steam rises up the short column and moves into the side arm and onto the Liebig condenser. The thermometer allows for the careful monitoring of temperature. This allows us to avoid exceeding the desired boiling point temperature we want to maintain for the experiment. In this case, I'd be monitoring to ensure I'm not massively exceeding 100 degrees centigrade, to ensure that I'm only boiling the water and there's no possible chance I could boil anything else, like the salt, for example. Now, of course, that couldn't happen here because salt has a much higher boiling point than water, but for substances that have closer boiling points, that might be necessary. Now to expand upon the role of the Liebig condenser in the experiment. The Liebig condenser is a collar of glass that surrounds an inner tube of glass running through the centre. Now, our water vapour would have been moving up into the column, into the side arm, and through that inner glass tube. As it moves through the inner glass tube, cold water will be flowing in and out of the Liebig condenser and all around that inner glass tube, cooling it down. And the key effect is it will both cool and condense that water vapour into liquid water, which will then run along the glass inner tube and out through the nozzle to be collected. It's really key that you say that the Liebig condenser has the effect of both cooling and condensing the water vapour back to liquid water. So finally, the pure liquid water, more generically known as the distillate for any distillation experiment, runs down the nozzle and into our conical flask for collection. And we'll keep running this experiment, keep doing this process until all of the water has been evaporated, and what is left behind in our round bottom flask is just a pile of salt, and all the water has been separated. And that's a successful separation of water from salt using a distillation experiment. Just before I finish off with a little bit more detail about exactly how a Liebig condenser works, don't forget that if you found this video useful, please do think about giving it a like, maybe think about subscribing to the channel, or even ringing the bell to be notified of our latest content. I'm trying to put up videos on a weekly basis, and your support is always hugely appreciated. And if you know of other people who need support in chemistry, please feel free to spread the word so this channel goes out to a wider YouTube community, because my aim really is to make sure that everyone gets a good experience of chemistry, and that's the point of these videos. So thank you so much for your support in advance. It is hugely appreciated. And now back to the video. So you may have been wondering, or not, why is it we have to put water in at the bottom of a Liebig condenser and then allow it to be pumped out the top for it to work effectively? Why can't we just pump the water in at the top and allow it to flow down to the bottom? Well, actually, there is method in this madness. I'd like to explain that now. By pumping cold water in at the bottom of the Liebig condenser collar, it's entering under pressure. That means that it's being forced throughout the entire interior of that collar and then pushed out the top. That means that the entire surface area of that collar is effectively cooling the inner tube. And that means we're getting the maximum effect in terms of cooling and condensing potential of the Liebig condenser glass collar. On the other hand, if you pump water in at the top of the Liebig condenser and let it flow with gravity downwards, well then it's going to take the root of least resistance and just flow leisurely down the bottom of the collar and out the bottom. It means that about 75% of the surface area of the Liebig condenser glass collar is doing absolutely nothing in terms of cooling and condensing because it has no cold water filling it. So it would be a very ineffectual way of utilizing the Liebig condenser for a cooling and condensing of any gases moving through the interior tube. So the reason why you have to put water in the bottom and it comes out the top is to make the Liebig condenser actually work. So there you go. If you ever wondered that, now you know. And knowing is half the battle. That about wraps up this summary of simple distillation. Thank you so much for watching. I really hope it's been helpful and useful to your understanding of that process. And I really look forward to seeing you on the next video. Thanks very much. See you later.